welcome to day 3. I have the luxury of introducing a session that probably doesn't need an introduction because the two gentlemen who are presenting have done a great job in previous VTs at actually presenting our security messaging. This time I've asked them to do something a little bit different. So in the previous VTs, you've seen Anthony and Robert come up and speak about the products and how they map to the industrial industries and introducing new products like the ISA 3000. This time, I've asked them to take a look at some of the emerging products and the acquisitions that Cisco has made over the last couple of years and how they fit into our security story as it relates to IoT. So with that, I'll turn it over to Anthony Sabella.
What can you expect for the next 60 minutes? So as Brian alluded to, we were asked to talk about some of the newer technologies and acquisitions and if and how they could be leveraged in IoT verticals. The network is a sensor. So as all of these cloud services are popping up and our attackers are getting a little bit more keen by the day about evading our security measures, network behavior analysis, I'm going to refer to it as NBA because I'm going to say it so many times, but NBA, it's in high demand. And there are many ways to provide visibility into traffic. And I often get this question, why do we need NBA? Why don't we just use our firewall IPS? Well, we can, but they act very differently. So I want to quickly explain the difference so you can understand how the technology can be positioned in complementary fashion, and then we'll jump into network as a sensor. So firewall IPSs, what they do is they look at TCP streams and they measure them against known attack signatures. So when I see a stream, I say that matches threat A. I see another stream, that matches threat B. So you're essentially triggering events based on isolated, singular attack matches. Now, it's needed, but NBA works a little bit differently. That's going to measure or analyze your behavior over a period of time. So this is going to analyze fluctuations in an index. And if that index exceeds a configurable threshold, I can tie that to an actionable response. So firewalls and IPS absolutely need to do a great job of detecting known threats. But for threats that are purposely built, like APTs, to evade that type of technology, that's where NBA comes in. Now, how this becomes particularly attractive is that we can leverage the customer's investment in their access architecture. So with all of their switches, their wireless controllers, their routers, their firewalls, we can turn them into NetFlow sensors, lighting up NetFlow on them, hence the term network as a sensor. Now, for those who aren't familiar with NetFlow, how many people have used NetFlow or know what NetFlow is? Just a show of hands. Oh, a large majority, which is great. So it is a protocol developed by Cisco back in the 90s. And it's like a telephone bill for your network usage. It's pretty neat. So it provides visibility into all the conversations going on. Who's communicating with who? How long is that conversation going on? What protocols are used? Over 100 different variables this gets. So you can see behaviors, statistics, performance metrics, etc. So you light up NetFlow, you collect stats on the various interfaces of your infrastructure. You package those up into binary format into a NetFlow record. You insert it into a UDP packet. You forward it to a collector. So now we can start analyzing behaviors and performance metrics. So let me show you a quick example of how this would look or work. On the left-hand side, you see a device that looks like it's doing something wrong, or should look like it's doing something wrong. And let's just say that's an HMI running Windows 7. Let's say that it got compromised, and it's sending 2 gig of traffic at a certain time in the morning. So as soon as this starts sending that traffic, we have our infrastructure sending NetFlow to the collector. Now, since that's captured, that's a suspected data alarm that's going to fire. Now, that suspected data alarm could be sent to the email address or the alias to the network team so they know, hey, HMI1 is acting out of the ordinary, take a look at it. This technology not only provides security, but introduces a level of automation that I think will be a welcomed addition for some admins. Now, the brains of the TrustSec architecture is our identity services engine. So this is a centralized policy engine. It allows a customer to take a business policy and translate that into technical rules that will be enforced electronically throughout their network. And when you see network door there on the left, the 3 major ways that an endpoint gains access to the network, we'll call them network doors: wired, wireless, remote access. Instead of going to each one and configuring NAC policy, we're going to configure policy in one spot and just point the infrastructure to it. And this is going to automate the segmentation and the ACLs, and I'll talk about that in a minute. So how does TrustSec fit into that? Well, TrustSec's a fancy term for our equipment working together using something called SGA, Secure Group Access. And instead of providing policy on an IP address, we can do something a little more comprehensive. So we can create policy and leverage things like username, device type, AD group if they're using Active Directory, location, even time. Maybe you have a contractor that comes in between 8 and 5, Monday through Friday, but if they come in on the weekend, you may want to differentiate their access. So we can take all these variables and couple them together and form a role, true role-based access, and we're going to associate a tag with the role. Now this tag, a secure group tag, is pretty neat. So think of a physical security badge. All of us have Cisco badges. You walk into a Cisco office, you go to the front door, your card key in, green light, you're good. You might walk throughout the office, try to get into another office, and you might be allowed in. You try to get into the server room, red light, you're denied. So instead of a physical security badge, this tag is logical, and it's attached to all your network traffic, and it represents your access, and it follows you wherever you go. So you walk into a manufacturing zone and connect into a switch, you get a tag. You disconnect, you go back into their business office, you light up your wireless, you get a tag. You leave, go to Chicago, go to the UK, this tag follows you. And it's software defined. So we don't have to go to each switch and wireless controller and firewall and create these policies. We're going to create the tags and all the policies centrally into the identity services engine, and again, point the infrastructure to it. So what does the tag, what does a secure group tag look like? So the tag, take a look at that left side frame. It says Ethernet frame. So you got a destination MAC, source MAC, 802.1q, VLAN. That's essentially a VLAN header. And then you have what's called CMD, Cisco metadata. Now within that Cisco metadata, that's where the SGT resides. And the overall layer 2 frame impact is around 20 bytes. So if you have an Ethernet frame at 1518, add 20, 1538, it's still far less than a baby giant, which our switches pass by default. Now this is a pretty neat slide that shows the difference between traditional segmentation and TrustSec. So traditional segmentation is typically based off of topology. So a VLAN, a subnet, a VRF. And when you're creating a VLAN, you're essentially just creating segmentation. But depending on how large your network is, how big your plant is, how large your substation is, et cetera, there may be a need for these VLANs to be trunked throughout the organization. And I think everyone knows that that's not always the case with most companies, not as prevalent as you may seem. Additionally, if you look at where it says hundreds of ACLs, static ACLs are being created. And you don't really know what's behind an IP address. So as all these new servers and applications are being decommissioned, no one ever removes the ACLs. So you go into these boxes and you're looking at all these access control lists. They're never removed. You just keep adding to it. And you can't remove it because you're not sure what pinhole you might create. So as you're creating policy, these access control lists are getting larger and larger, and you could even be challenged for TCAM space. But bottom line, there's a lot of manual configuration going on there, which essentially widens your risk exposure and increases your likelihood for error, hence the need for automation. So with TrustSec, that's a lot different. So instead of creating policy at each switch and wireless controller firewall, we're going to create it in one spot here at the Identity Services Engine. And instead, we're just going to point the access infrastructure to it, your switches to it, wireless controllers to it, firewalls to it. So as an endpoint attempts to gain access, they're examined by the Identity Services Engine and pass back their privileges in the form of this secure group tag. So now we're creating the policy centrally. Second is not only is the Identity Services Engine automating the tags, and the tags is essentially segmentation, it's also automating all the ACLs for you, which is pretty neat. You don't have to touch the customer's VLAN assignments, nor their IP ADI schemes. You can leave those completely intact and add TrustSec on top of it. And where you see micro-segmentation there, since we're configuring the policy in a centralized spot in ICE, we can provide micro-segmentation. So you see those 4 endpoints that are generating traffic there. Let's just say that's zone 1. I can provide segmentation in that zone. So that zone 1, even if it's a singular VLAN, I can chop it up and make it look like multiple different VLANs based on these tags, do it without touching their VLANs, do it without touching their IP ADI scheme.